So I'm going to apologize up front for the poor video quality. My best videos are made at school, and I'm here at home now getting ready for jury duty. But anyway, the focus that normally stays focused in this app that I'm using for some reason isn't working as well as it normally does. So I'm not sure, but we'll just try to get through it. Bottom line here for problem number 2, we're supposed to try to figure out what is the x that will minimize the function that you created in 2a, and it was the distance between a point and a curve. So you should already have d of x defined, and if you're using a calculator, you can go ahead and follow here. You can use Desmos as well, and you just want to go ahead and type in the function x squared plus x squared minus 7 also squared, quantity squared. So that's our function, and on a graphing calculator you can try zoom 6 to get the standard viewing window, and in Desmos you can just zoom out just so you can see the graph. Now, as you can see, the function d of x is graphed here, and that the function represents the distance, like I said, from that point to the curve depending on the x. So let's say, for example, we trace the curve. If you look here at the coordinates on the very bottom of the screen, it might be a little hard to see. If you look at the coordinates on the bottom of the screen, you can see when x is 0, y is 7. So just to understand what that means, when x is 0, then the distance between the point and the curve is 7. So I think I remember the curve being x squared minus 8. So x squared minus 8 and then 0, negative 1, the distance is 7. So if you move x to the right a little bit, you can see, let's say when x is a little bit more than 1, the distance from 0, negative 1 to the curve would be 5.97. And so bottom line is right down here, you're going to get that minimum distance because that shows a minimum value on the curve, and then you're going to have that same value over here to the left. So in Desmos, you can just click on those minimums. Those are the absolute minimums because it's symmetrical with respect to the y-axis. So those y values are going to be the same. On the graphing calculator, you have to hit second trace. So you want to calculate, and you're going to calculate a minimum value. So you hit enter, and then to the left of the left, so you want to mark a left bound. So move your cursor to the left of that minimum, mark it with an enter, and then move your cursor to the right of that minimum, mark it with an enter, and then back it up a little bit. Hit enter again for your guess, and that will show you that the x coordinate is negative 2.55. So when x is equal to negative 2.55, you have a minimum value of the function 2.598. It's not asking for that, but that is what the minimum value would be. And then if you want to go ahead and repeat that same thing for the minimum value on the right-hand side, you again calculating minimum. You can move the cursor over here anywhere, and then asking for a right bound, you want to move the cursor to the right of that minimum. You can see in Desmos it's a lot less work. You just click on the point and you'll get the x equals also 2.55. You can round to the nearest 2 digits after the decimal, and we still get that same minimum value for the function d of x, which represents the distance from 0, negative 1 to the point on the curve. Okay, so hopefully that helps you understand, number one, how to get that, but then also what it actually means. All right, so I'll make a new video for each problem.